Chapter 5, Part 2, Newton's third law of motion. We mentioned before that action and reaction forces act on two different objects. That's two different masses. Look at the example here. We have a cannonball sitting initially inside a cannon. The two objects in the picture are cannonball, which has a small mass, and the cannon, which has a big mass. Initially, everything is at rest. What happens suddenly is that the cannon is pushing the cannonball with a force to the right. But the cannon itself will recoil back to the left. Also, we notice that the cannonball will come out very fast, so it will have a large acceleration, whereas the cannon itself will recoil with a smaller acceleration. Why is that? The idea is the following. You have two objects and there is the same force acting on both of them, the action and the reaction. Now, if you think about the small mass, the force F acting on the small mass will produce an acceleration. But because the mass is small, then the acceleration will be large. As we mentioned before in the previous chapter, when mass is small, the acceleration will be large because mass and acceleration, they are inversely proportional. Whereas for the large mass, capital M is big. So when you divide the force, which is the same as the previous force, same force, if you divide it by capital M, that's the big mass, it will produce a small acceleration. So the reason for the large and the small acceleration in the picture, because of the two different masses. So we have the same force, but two different masses. The small mass will produce large acceleration, while the large mass will produce a small acceleration. Look at the picture here and answer the following question. When a cannon is fired, the acceleration of the cannon and the cannonball are different because... So what's the answer? What's the reason? Why the acceleration of the two objects are different? Think about it. The answer is C, because masses are different. Let's take another example. A big truck is hitting a small car. Now, is the force of impact the same on each car? And then, is the damage the same? Well, obviously, here we have two objects, two cars, big one and small one. Now, which force is bigger? Are they the same? Well, according to Newton's third law, the two forces are the same. They are action and reaction. So the truck is hitting the car, the small car, and the small car is hitting back the truck. The two forces are equal. Believe it or not. But the question is, why the damage is not the same? It's obvious that the damage is different, and the small car is damaged much more than the big one. Can you answer this? Well, it must be due to something else. The two forces are equal. But why the small car is damaged? There could be a few reasons. For example, the material used to build the small car is weak, so it gets damaged quickly. It's similar to when you hit a glass with a stone. The glass will break easily, but if you hit a wall, a concrete wall, with the same stones, same force, not much will happen to the wall. That's because the material of glass is easily breakable. Another question. Consider a high-speed bus colliding with a small bug. Now the force of impact splatters the bug over the windshield. Now which force is bigger? The force on the bug or the force on the bus? Remember, there are two objects in the picture. There is the small bug and the big bus. They are colliding, they are hitting each other. Which force is bigger? Think about it. The answer is, believe it or not, both are the same. According to Newton's third law, action and reaction forces are equal. Now, why the bug gets splattered easily over the windshield? Why nothing will happen to the bus? Can you answer that? We will talk about this again in class. Another question. Two people of equal mass on slippery ice push off from each other. Will both move at the same speed in opposite directions? Remember, here we have two objects, that two people, and they have equal mass. So what's the answer? The answer is yes. They will move with the same speed in opposite direction. And the reason is because the two forces are equal and the two masses also are equal. So they're going to produce the same acceleration, which will move the two objects, the two people, same speed, but of course in opposite direction. Another question. Now we all know that Earth pulls on the moon. So does this mean that the moon also pulls on Earth? If so, which pull is stronger? So what's the question? What's the answer? Well, again, you have two objects, Earth and the moon. Both objects are pulling each other with the same force. Action and reaction. I have this question to think about. We will discuss it in a class in more details, but since action and reaction forces are equal and opposite, why don't we just say they would cancel out to be zero? Because they are equal and opposite. So they cancel out and that's it. So why do we bother? Now, remember something very, very important, that action and reaction forces, they act on two different objects. So if you pick one of the objects, just one of them, how many forces on the object? Okay, think about it and we will discuss this also in a class. Let's finish this part with another question. We have two teams, boys team and girls team, playing tug-of-war. The boys are wearing socks and the girls are wearing rubber-soled shoes. And the question is, which team will win and why? So think about it. We will also discuss this question in details in the class. So leave you with that to think about.